thank you all for coming. As David mentioned, I've been the director of the Lister Hill Library here for the last nearly 20 years. Really a fabulous time to be a librarian, as we have seen tremendous changes in how information is gathered and shared. It certainly has completely revolutionized my field. It has revolutionized many other fields. And over that time, and some of the things that David mentioned allude to that, I've spent a fair amount of time on a variety of projects involved with how do we do a better job of sharing information. Some of you are familiar with the open access movement related to publications. Are there ways that we can do a better job of sharing peer-reviewed publications? And there's been a lot of activity around that over the last 20 years. I've been involved in some of those pieces. But along with that, we've seen this increasing interest in dealing with data itself, that the digital technologies give us some opportunities we've never really had before. And that has really become a major interest of mine, and I've worked on a variety of things nationally and internationally in that area. So about nearly a year ago now, as things were moving ahead with the reorganization of the libraries, I had some conversations with Suzanne Austin, the vice provost that the library directors reported to, about what I wanted to focus on going forward. And out of those conversations, we sort of came up with this general sense of looking at data, looking at the issues that an institution like UAB might face. And so we came up with this fancy title for me. And I spent a fair amount of time during the first couple of months trying to sort out what that actually meant. And the way that I've come to think of it, and what I've been doing for the last couple of months, is really trying to sort out what are the opportunities that an institution like UAB has in this emerging world of open data, and what are some of the challenges we face organizationally in really trying to take advantage of that. So what I want to do today is tell you a little bit about some of the stuff I think I've learned, some of the things that I think we can do in the short term, and then some of the things that I hope we can work on over time. And I really see this as what I hope is the beginning of an ongoing conversation. Those of you who know about the Edge of Chaos know that part of the goal of the Edge of Chaos is to bring people together to work on wicked problems. And it seems to me that really effectively dealing with open data is a wicked problem. So I hope that we'll be able to have a series of conversations up here starting today. So after my talk, those of you can stick around. If you'll join me in the cafe, I'm going to persuade David to open a bottle of wine or two, and we can continue the conversation for a while this afternoon. Now, coming out of library land, we tend to talk about ourselves as information professionals. And all of you know that we've been in the so-called information age for the last couple of decades. And we think about this kind of a pyramid where you start with data, and you combine that and you get information, and that leads to knowledge, and that leads to wisdom. And of course, the truest thing about this kind of pyramid is there's a whole lot of data and not very much wisdom. But we keep working towards it. But we spent a lot of time thinking about the information side of things and haven't really done a lot of talking about data until the last few years. And it seems all of a sudden we're hearing more and more about data and your data and what's being done with data and how it's being accumulated and who's using it and is the NSA snooping on us. And it's really become more and more the trendy thing. So it's like we've moved away from the information age into something about the days of data, and data's become the new bacon. So that's really what we're getting all excited about. So we hear about things like big data. And for those of you who were here at Thomas Anthony's talk last week, he gave one of the best descriptions of this very amorphous and vague term that everybody kind of hears, but doesn't really know what it really encompasses. And I think, sort of in a nutshell, part of what I took from Thomas's talk is you're dealing with big data when you've got sets of data that are large and complex enough that the technological tools that we have to analyze them and make sense of them are a little bit beyond our capability, where we're kind of pushing that boundary. Now, we think about big data frequently in this whole large social sphere. So it's all the data that's being collected about you, that marketers are using, that the NSA is terribly interested in, and you try and balance the privacy aspects with the marketing aspects. But if we start to narrow it down a little bit to the kind of things that I'm principally interested in terms of research data, you're looking at how does that data really support the scientific enterprise? Are there ways that we can use data to do better patient care, to do better science? So what does it mean if you're looking at big data in that context? And I do try to remind people when we talk about this, that although we get enchanted with the sexiness of the great big petabyte data sets, if you're an archaeologist, pottery shards are data. And to the extent that you can describe pottery shards digitally, those are important data sets. And to the extent that we can start to combine the work of different researchers, we start to aggregate data, and we're back in the world of big data, even though we're dealing with sets that come out of more traditional research. So you see this reflected in something like the NIH's Big Data to Knowledge project, BD2K. This has been underway for the last 2 years. 2-3 years, NIH is starting to put some money into a whole variety of projects to try to figure out how do we grapple with big data. And within the context of this project, they think about big data really in 3 broad areas. So there's the individual research group that is doing work that is generating huge amounts of data. Thomas talked about the brain mapping work that's being done here. That's a really good example. They are generating huge amounts of data and then trying to figure out how do you make sense of it, how do you get new knowledge out of that. And then there are collaborative projects where you've got a number of different research groups who are depositing data in shared repositories. So they're working on similar but related projects, aggregating that data so that they can link up these different projects in new and exciting ways. A lot of the genomics research that we've seen is done that way. The GenBank is kind of the granddaddy of shared data repositories. But then there's also, and this goes back to my slide of the pottery shards, there's also now the opportunity to take lots and lots of little projects where we never really had an opportunity to share that data systematically in the past and start to collate that together so you're starting to build big data sets out of much smaller data sets and really look at applying new knowledge, again, in ways that we weren't able to before. So big data really encompasses all these ways of looking at the kinds of research data that we're collecting and that we're trying to make sense of. Coincidentally, this showed up last week. The Scholarly Kitchen is a blog that focuses on the publishing arena, STM publishers. And it's really an ongoing conversation about how do scientific publishers grapple with all of the changes that we're facing. Here they're asking the question, are we this tipping point of open data, and what does it mean for publishers? As we're starting to look at the possibility of sharing research data, where do publishers fit in? And we're starting to see publishers really thinking about should they be doing some of the peer reviewing of data sets? Should they be requiring the data sets be published along with the journals? What does that mean? So they're looking at how their role is shifting and changing in much the same way that the rest of us who are part of this much larger scientific community are also struggling with. Now, in the print world, as you know, the typical way of sharing information was individual research projects. You generate your data, you analyze your data, you write up your results, you write up your conclusions in a paper, you publish it in the peer-reviewed literature, and that's how we have kept track of science for, these 400 years. And rarely was the raw data in any large or systematic way shared. You'd publish maybe a little bit of data, a little bit in a figure or an article, but you really didn't do much with the whole data set. So the data sets tended to be what was left over when you were done with your work. And if they were digital, maybe they were on a hard drive somewhere. Maybe you and your lab partners kind of understood the data, but anybody else looking at the data set wouldn't have a clue what it was really about. And they didn't need to, because we didn't think about sharing data systematically. Starting in, say the 1990s, the early 2000s, people started to really look at the potential, now that we have the kinds of digital technologies that we have, for really starting to make that data more available and sharing it in systematic ways. And so you see things like the NIH data sharing policy from 2003. Starting in 2003, NIH required that any grant application where you were asking for more than $500,000 in direct costs had to include a paragraph indicating what data you would be collecting and the degree to which you would be willing to share that data if it was requested by an appropriate mechanism. It was a very, very thin policy, didn't really have much specification in terms of what had to be in that data sharing plan, but it started to plant that seed and get people thinking about it. And the rationale was this notion that if you are effectively sharing data, then you're promoting open scientific inquiry. You can develop new hypotheses. You can do error checking. You can look at, can things be replicated? So people were seeing a lot of potential for what we could do if we could get to a system where we were effectively sharing data broadly. So once you start to think about the idea behind it and kind of buy into that, yeah, that would be a good thing, then you start to look at the complexities and what does that really mean and how do we go about doing that. So David mentioned a project that I was involved in back in 2009 that became known as the Scholarly Publishing Roundtable. This came out in part from a lot of the open access to publications discussions. The NIH public access policy had been made mandatory in 2008. The public access policy requires that if you are publishing out of NIH-funded research, you have to make a copy of your paper publicly available through NOM's PubMed Central. And there was a lot of pressure on Congress to extend something like the NIH public access policy to the other agencies. At the time, the debates got pretty contentious. And there were a lot of people on all sides of the debate making pretty extreme claims about how open access is a moral mandate that will save science, or open access will destroy science as we know it because it will eviscerate publishing. And quite frankly, people in Congress were trying to figure out how do we thread through this and really make some sense so that we can try to develop sensible policy. So the Scholarly Publishing Roundtable was pulled together at the request of Congress to develop consensus recommendations that could be used to inform policy. There were 14 of us in the group. There were 3 librarians, 3 university provosts, representatives from the publishing industry, commercial and non-commercial. We had some research support. It was chaired by the executive vice president of the Association of American Universities. And we delivered our report to Congress in January 2010. And the major recommendations said, essentially, this is a very fluid area. Individual agencies need to develop their own policies for sharing publications and sharing data, working in concert with their disciplinary constituencies. There needs to be flexibility in these policies because things are going to change over time. And they need to be developed with a lot of input from all of the stakeholders. So the recommendations were incorporated into the reauthorization of the America Competes Act in December of 2010. And the language in that basically directed the White House Office of Science and Technology Policy to direct the federal funding agencies to develop policies along these lines. And in the, as the wheels turn in government policymaking, finally in 2013, so about 2 years ago, a memo comes out from the director of the White House Office of Science and Technology Policy, John Holdren, directing the federal agencies to do exactly that, to come up with individual policies for how to make publications and data that result from federally funded research publicly available. So this is referred to, you'll see this referred to as the Holdren Memo, the OSTP Public Access Memo. In the memo, the agencies were required to deliver their draft plans within 6 months, so that would have been fall of 2013, and then there would be some back and forth, and eventually policies would actually be released. So for about a year we heard nothing, and then starting about 2 months ago, we've started to see the policies being released. And there are some similarities and there's some variations in what is coming out from the agencies. Now, one of the things that they all do look at consistently, what is research data that we're looking at here? Because as you know, if you look at a research project, there's all kinds of stuff generated. And so you need to think through what are we really trying to make available, to describe accurately. And so they try to narrow it down to the digitally recorded factual material that we typically use to justify the results in a peer-reviewed paper. So that's the kind of data that we're concerned about. Now, as each of the agencies is coming out with their policies, they all have something dealing with publications and they all have something dealing with data. So you look, for example, National Institutes of Health, they have their public access policy for publications, so they've got that taken care of. They are now going to extend the data management plan requirement to all grant applications. So starting in the fall, it won't just be grant applications for more than $500,000. It's any NIH grant application is going to have a data management plan as part of that. They will be coming up with more detailed specifications for what has to be in that plan, and then starting to develop metrics for how to find out if that plan is actually being followed, and does the institution actually have the infrastructure in place for the plan that the investigator puts out. AHRQ has a slightly different version. They're also going to use PubMed Central as their repository, but they're going to contract with a third-party data repository that will be the site for the data that's generated out of their research. So if you're getting funding through AHRQ, you're also going to have to make sure that your data set is appropriately deposited in whatever third-party repository they pick. Department of Energy, just another example, has taken a very different tack. For publications, they are going to rely primarily on a publisher-driven project called Chorus, in which participating publishers will make copies of articles available on the publisher's site. So if you are publishing with a journal that participates in Chorus, you're taken care of as far as energy is concerned. If you're publishing in a different journal but you have a local institutional repository, you can put a copy of your paper there. Failing that, DOE is going to set up their own repository that they're calling Pages, and you can put your article there. So a few more hoops that people funded through energy are going to have to deal with. They are in the process of developing more specifications, again, for their data management plan. So we're starting to see this from all the agencies. This is a crowdsourced spreadsheet that's popped up in the last few days that is being worked on by librarians from number of institutions trying to track these different requirements. So we're moving into a world in which, as we're looking at grant-funded activity, we're going to have to be paying more attention to what are the requirements for what you do with your publications, what do you do with your data, The really fun part is going to happen when you've got projects that are funded by multiple agencies that have different sets of requirements, and trying, we hope, to make sure that you can address the requirements of the different agencies without those requirements coming into conflict. This is the federal government. Imagine that that would ever happen. I'm not concerned. Now, it's not just the federal government that is looking at this. The independent funders, the Gates Foundation came out with their policies a couple of months ago. Howard Hughes Medical Institute has been in this ballgame for a long time. And as I alluded to earlier, we're starting to see the publishers as well. Most of the major publishers in the STM world are really starting to grapple with the question of data, starting to institute policies that will require that you indicate to what extent your data is going to be available, how the data is going to be shared. And to some extent, some of them nudging towards policies where they are actually going to expect you to submit the supporting data with the article, and the review of that is going to become part of the peer review process. Particularly in clinical trials, this is moving ahead at a pretty good clip. Obviously, for an institution like UAB, this starts to have some pretty significant impacts. So this is the environment that we're moving into. It's moving very quickly as the agency requirements are coming out, as publisher requirements are coming out. So the question then is, what does it mean for us? Or to really try to focus it on, how do we as an institution adequately support the research community so that researchers have the kinds of tools, the kinds of infrastructure, the kinds of services, the kinds of guidance that make it as easy as possible for them to participate in appropriate data sharing, in developing open data policies, in making sure that the institution as a whole is in compliance with all of these, and that we do it in such a way that there is as little burden as possible placed on the research community, which is already aching under the burden of regulations and compliance. I don't actually have a next slide that gives the answer, just in case you were waiting. But I do have some ways to think about it. This is out of Johns Hopkins University, and it's kind of dense. Don't worry about the outside pieces. For this purpose, I'm interested in that center part, where they think about data management as this series of layers. So you start by thinking about, you just need places to store data. And then if you think about archiving, you're starting to apply some organization to it, you're starting to apply some description to it. Then you need to think about preservation. How do we do this over the long term? Make sure that the data remains reliable, remains sound, does not get corrupted, and then eventually get to the point where you're really dealing what we think of as curation, where the data is so well described, where it's findable, where it's permanent, where we really are then in an open data environment where we can make use of that data to start to do the kinds of things that were indicated in that paragraph from a dozen years ago when NA had set up the data sharing policy. So the question becomes, how do we organize things at a research institution like this to start to pull these things together? And I find it useful to think about it as these sort of interlocking spheres of services, infrastructure, and policy. These are the areas that we need to grapple with. So in infrastructure, we're looking at things like, obviously, storage options. And storage options are not simple as you get into this. Because depending on the discipline, depending on the project, there may be very different options that make sense. It may make sense, depending on the lab and the project, that local storage really meets the needs and can be handled over the long term. It may be institutionally developed services where it's UAB servers that are managing this. But then there are larger collaborative projects. There are third parties, both commercial and non-commercial, that are moving into this space. You've all heard about cloud-based solutions. So there's lots of options, and the challenge is going to be, how do we make sure that we are matching a particular research project up with the appropriate storage solution that is going to get us where we want to go, meet all of the requirements, and be the most affordable and most logical for that particular project. Analytical tools. And again, going back to what Thomas talked about last week, we really are pushing the boundaries of what we can do with the data sets that we have at hand. So what can we do? What additional tools do we need to put more resources in the hands of the research community to work on these? Training and support for all of this, metadata services so that we're describing data appropriately during the life of the project. We get into the policy side of things, and obviously it's things like compliance with all these funder requirements. How do we make sure that as an institution we are giving the right kind of guidance to the research community to say these are the things that you need to be doing with your data in order to make sure that we are meeting all of the rules and regulations. What does that mean in terms of best practices? Right now we have we have some guidance out of the research office about how to deal with data. IT has guidelines for dealing with data. The graduate school teaches courses on how to deal with data. We need to make sure that all of these are consistent, that we're giving a straightforward and clear message to the research community and how to deal with this stuff. And then what I think of very broadly as services, how do we help the research community with developing data management plans, with making sure that when you're doing a grant application, you have the right kind of data management plan that is going to meet the requirements of the agency that you're dealing with. There is a very nifty service that was developed out of the University of California system called the DMP tool, and it can be branded and implemented on a local basis. It's essentially a series of templates that cover a whole variety of funders, both government and non-government, and it really just walks you through the steps that are required to do a data management plan depending on who the funder is. Information on meeting all of the funder and publisher requirements. Metadata services again. We're doing some of this now. There's a very good collaboration between the libraries and the research office in support of the NIH public access policy. So we have an opportunity to extend that as we start to deal with other agencies and other requirements. Along with metadata services, things like DOI assignments, digital object identifiers, how do you make sure that wherever that data set is, it's got a permanent assignment so that you can link to it and you can start to track it in the same way that we track publications currently. What's required then is all sorts of entities across the campus and all sorts of people across the campus who have a clear interest in some piece of this to figure out how to work together collaboratively to address this whole broad set of issues. One of the things that is very clear as you look at these problems and you look at every other research institution in the country that is dealing with this, we have not organized universities in such a way that responsibility for this whole broad problem clearly falls in anybody's basket. So it really requires the research office, IT, the libraries, centers, the labs, to figure out how to work together collaboratively to pool expertise, to pool interests, to pool the work that's currently being done in order to maximize the use of the resources that we currently have at hand, but then also to identify the gaps and figure out how we work together to fill those gaps. Now we have a lot of pieces in place currently. I get asked, so where are we in relation to other institutions? We're a little bit behind some, we're ahead of others, we have some pieces in place. Nobody has figured out how to do this comprehensively, but there's a lot that we can learn from other institutions, but there's an awful lot that we have in place now that we can expand on. There's things like the High Performance Computing Unit, the group that John Paul runs, that has very sophisticated analytical tools, has extensible storage. I think part of the challenge there, and John Paul can correct me if I'm misstating, but how do you take this operation that works in this kind of quasi-pilot mode and really make it operational and extensible across the university? But it's a very important building block that we can do more with. The Big Data Research and Analytics Laboratory that Thomas Anthony runs out of the School of Engineering works very closely with high-performance computing. We have the informatics group out of the CCTS that provides some services along these lines, and now the Informatics Institute out of the School of Medicine. We've just hired Jim Cimino as the director of that group. Cimino is easily one of the top 2 or 3 people in biomedical informatics internationally, and having him come to UAB is a huge step forward for us. We can certainly expect to see a lot of advances in how we make use of our clinical data in particular. The clinical data per se, not strictly speaking the kind of stuff I've been talking about here, except when we get into clinical trials. And then again, we're starting to look at data that is generated out of the research side. And so there is that intersection between what the Informatics Institute is going to be working on and the kinds of things we're talking about here. I mentioned the support that is currently being done for the NIH public access policy, an important piece that we can build on further. The Faculty Profiles Project that Midge Ray is leading out of the Provost's office, which, when it is fully implemented, will provide a standardized way of looking at the research activity, the grant activity, the teaching activity of faculty across the university. It becomes a key building block in giving us the ability to really identify where the pockets of expertise are, where the real strengths of the institution are, and how we hook people up across the university. I mean, one of the challenges that we face at UAB, and again, like every other institution, is we don't know what all is happening here. We don't know if you are doing research in a particular area, that there's somebody down the street who's doing work that could be tremendously key to what you're doing, and these are tools that are going to help us figure out how to bring those people together. Ewan Alexander, Dean of Engineering, has been working with a group to develop a strategic plan for research computing. That was just presented to the strategic planning retreat last week. It lays out a 5-year plan for the kinds of investments that we need to make in infrastructure, in staffing, to really get us to where we need to be to really support research computing broadly. Again, data management piece intersects with all of that. And then, you know, tons of individual projects. And part of what I'm trying to sort through is how do we really identify and surface those so that people really have a good understanding of what is happening in this area across the entire institution. What's missing? Clear policy guidance, range of affordable storage options, access to good sources of information. Just where do you go to find out what's happening and what's actually available? And coordination of efforts, because there's all kinds of pockets. What we don't have is a way to pull all of those together. Some of the simple things that we can do, if you look at what some other institutions have set up, these are coming largely out of libraries. Very simple guides to what's available on campus. This is out of the University of North Carolina. It's one I particularly like. If you look at the tabs, they've got information and agency requirements, how to think about your data needs, particular resources that are available at the institution. So I've been working at setting up one of these for UAB, out using the library's template. Again, pulling together some of the stuff that I've been talking about here, just so that we've got a single site that we can start to build collaboratively that pulls together the kinds of information that people need. Looking a little further down the road, some of the things that I think we need to focus more on, things like the Orchid ID. How many people here have an Orchid ID? It's not nearly enough. How many know what Orchid is? That's a little bit better. That's still not nearly enough. Orchid, very briefly, is an international collaborative effort to assign individual IDs to individual researchers to address the problem of people with similar names publishing and individuals publishing under different names. So how do you really pull together all of the work of a particular individual and know that it is this particular individual and not somebody who has a similar name? It's a fundamental building block to being able to really identify where research is being done, who's doing that research. Many people who work in this space really see promoting Orchid and getting the research community on board with that as a fundamental building block. Vivo is an example of a kind of collaborative system that builds on the kinds of things that you see in the Faculty Profiles Project to make it easier to look at research across the board, to look at what's being done at other institutions. Many of the CTSA-funded institutions have implemented Vivo and are using it for their collaborative activities. Again, how many people here are familiar with Vivo? Oh, we have work to do. And then I mentioned earlier things like digital object identifiers. Lots of little tools and things that I think over the course of the next few months, part of what needs to be done is really getting information to the research community about what some of these tools mean, where there are relatively easy wins that we can get without investing a lot of time and resources as we start to develop plans for the long term. All of this in the service of the long-term goal, which I would think of, for example, if we could really develop a catalog of really well-organized, contextualized, searchable, shareable data sets that cover the entire range of UAB research. So there was a place that you could go, you could find out what data was being developed, who owns it, where it is, how you use it, you could get into it and understand it. I came across this quote just earlier today. If the data exists, if you can find it, if you can understand it, if you can trust it, and then if you can use it, then somebody did a good job of data management. That, I think, is what we ought to be shooting towards. So, short-term goals. Get this online guide up, which I expect to have up within the next month or so. Implement a UAB-branded data management plan tool. Again, these are kind of high priority because if the federal funders come through with their plans, this is going to have an impact on grant applications that people are going to start working on this summer, as they do months ahead of the grant deadline. Promote Orchid, some of these other tools. Organize support for public access policy compliance, building on what we've done with the NIH public access policy. And then what I hope to do as part of it is, as I said earlier, here in the Educhaos, to try to promote some regular discussions informally, bringing people together like yourselves, other folks who are on campus, who are interested in these issues, who are interested in participating in these discussions. Want to start with that today. I believe that David has opened the wine. We should have a little bit of time here. We can have some questions here now, but then I hope that some of you can join me and hang out for a while afterwards. And thank you very much. That's the obligatory picture of my granddaughter. George.
You know, it's funny, I've never understood what data means.
I was trying to explain it to my granddaughter.
Yeah, but anyway, for example, I'm committed to sharing data. Regards one of the studies I'm part of, 70% of the papers written out of the study are written by people who are not affiliated with the study. I think that that's evidence that we can share. But if I write a paper and somebody says, provide the data that this paper is based on, that's easy. I can take an analysis data set. It wouldn't take but an extra week or so's work to do it for every one of the papers that we're writing. We're right now at a volume of about 50 papers a year.
Yeah.
And so we would need to have maybe 2 or 3 more FTEs just to get the documentation together for those. But then somebody comes back and says, I don't like your definition of blood pressure. And so what he has to do then is to go back further behind the curtain. And some of the things behind the curtain are very complex. And sharing the data that's behind the curtain, which I'm not opposed to, is nearly impossible. I mean, like we have a full-time person that works on a data set about where people are moving, and the person really understands that data set. God, if he gets run over by a train, we're dead meat. In CREST, we have 8 versions, 8 amendments to the protocol. Completely different forms evolved over the study. So there are 8 different data sets for one clinical trial, and we understand how to put them together, but sharing those data behind the curtain are impossible.
Yeah.
So I guess my question is, what is data? And why we...
Well, let me approach it slightly differently. What you're talking about really gets to the heart of this concept of data curation. So the vision is part of the research group at whatever level becomes data librarians, people who really have particular expertise in metadata and structure, and who understand the standards of the particular discipline, but also understands the standards that are being developed more broadly. So that from the get-go, somebody is working with the research team and thinking about the data not just from the standpoint of what your group needs, but also thinking about how do we make sure that the data is being structured and defined and developed, so that at a certain point, when there is a request for it to be shared, or when it goes into some kind of a repository, you're not faced with going back and trying to restructure a data set to meet a particular query. Now, the kinds of data that your group is dealing with and the amount of data is really on the far end of the challenge. So we don't have the tools and the workflow and the process and the standards. We don't have any of that in place now. But we have the concept. And so I think that people who are really doing the research in this area, who are working at it, they're looking at smaller data sets, they're looking at collaborative activities, to really try to define what kind of workflow is required, what kind of expertise is required to address that problem from the beginning. It's going to take considerable time and considerable work to get there. Some of what NIH is doing with the BD2K project is funding research into those areas. NIH has a grant program. It's an add-on. If you have an NIH-funded grant and you want to bring in a data librarian to work just on this, you can get a supplement of $25,000 a year to help pay for somebody to work on that. So there are efforts there. I think what you've described is exactly the problem that we're trying to address, and we're a long way from having answers to.
I would say for CREST, just as an example, I think you could do what you're talking about. It isn't that we don't want to do it, it's that we're not funded to do it.
Yeah.
And I think you could do it easily, and I'm not exaggerating, with, I would say, 4 or 5 FTEs that are getting paid $80,000 or $90,000 a piece. We could do that for one study.
Right.
And that is not an exaggeration.
No,
So just for an extra $500,000 a year, we could do this.
So again, the challenge, which I hope we will meet over time, is how do we look at that problem and develop the kinds of expertise, services, tools, etc., that enable us to actually address it at something less than, $5 million for one project. Other?
So maybe on that theme, I don't know if you've heard the term sheer curation. At least I ran across it some number of years ago. basically this idea that like a sheer curtain, something that you could almost see through, the curation that you would essentially establish along the way of your data pipeline. So
Right.
it wasn't something that you were like, okay, so data arriving, okay, now I'm going to sit down and curate it. Instead, you're inserting elements along the way, you're changing processes along the way in order to establish, maybe a mostly marked up or mostly curated data set that then requires refinement in order to put in its final form. How do you see those kind of efforts or technologies?
Well, the analogy, as imperfect as analogies are, is suppose that the Lister Hill Library had been developed in the way that data repositories currently are by people saying, oh, this is a good book, we'll put it on the shelf over here. And here's a good book, we'll put it over here, and we'll put it over here. And we ended up with a couple of million copies of books with no organization and no structure. The challenge of figuring out how to get all of that organized would seem insurmountable. But what we have developed over centuries is a set of processes so that every time we license a new item, we have a very systematic set of workflows and tools that enable us to take that one item and very easily move it into the system so that it is appropriately described and appropriately available, and it is just a bread and butter operational piece of what we do. That, I think, is the kind of thing that you're talking about. Where we are right now with data, unfortunately, is we're looking at a building full of books that have been thrown together haphazardly. And in a way, it's even worse because many of the books are locked. So even being able to open them up, and then when you open them up, and I think this gets back to part of what you're saying, they're in a language that only one person understands. I do believe that these challenges are addressable. But it's a lot of work, and it's going to take a lot of time, it's going to take a lot of research. But there are some things that we can start to do, and there are some things that we need to do as an institution to deal with some of the immediate challenges and opportunities.
Time for one more.
All right.
For those of you who know our rules, we always get you out within the hour, even if we start 5 minutes late.
One more?
One more, but, here, twist my arm. Oh, we might have some wine in the back if you want to stay around and talk to Scott.
We've got one here, yeah.
Is there much pushback on this? Putting data into open data sets in this place?
Less and less.
Good.
I would say that if you asked that question 10 years ago, there would be a lot more concern and uncertainty. And it varies somewhat by discipline. I think social sciences tended to incorporate a lot of their sense of data sharing 10, 15, 20 years ago. And they're dealing with smaller data sets that are easier to share. 4 or 5 years ago, I think you would get a significant amount of pushback from some basic sciences who are concerned about priority. There are areas, if you're looking at data that may lead to patentable stuff, where there are obviously some real questions. So it's still, I think it's more discipline specific and project specific, but in general, I think the sense that the principle of data sharing is a good thing if we can figure out how to do it well, and if we are alert to the fact that there are some cases in which we may need to be more restrictive.
Hey, let's thank Scott again.